Welcome back! In this lesson, we will determine the differential coefficient of the cosecant function, y equals cosecant of x, using the method of first principles. Let's break down the derivation together, step by step. We begin by writing our primary equation. Let y equal cosecant of x, which we will denote as equation 1. Next, we give x a small incremental increase of delta x, which produces a corresponding small change in y, written as delta y. This gives us equation 2. Y plus delta y equals cosecant of x plus delta x. To isolate our increment delta y, we subtract equation 1 from equation 2, giving us delta y equals cosecant of x plus delta x minus cosecant of x. Since dealing with basic sine functions is easier, we replace cosecant with its reciprocal, 1 over sine. Finding a common denominator allows us to combine these into a single fraction. Looking closely at the numerator, we can use the product to sum identity for sine of c minus sine of d. Substituting c as x and d as x plus delta x simplifies our expression into 2 times the sine of negative delta x over 2, multiplied by the cosine of 2x plus delta x over 2. Now, we divide both sides by our change in x, delta x. Remember that sine of a negative angle pulls the negative sign out front. We rearrange the terms to isolate our standard limit pattern, moving the factor of 2 to the bottom as delta x over 2. Taking the limit as delta x approaches 0 on both sides turns the left side into our derivative, d over dx of y. As the limit is evaluated, our special fundamental limit goes to 1, leaving us with a negative sign out front. For the second part, as delta x vanishes, the numerator becomes cosine of x, and the denominator becomes sine of x times sine of x. Separating these terms gives us negative 1 over sine of x times cosine of x over sine of x. Since 1 over sine of x is cosine of x, and cosine of x over sine of x is cotangent of x, we arrive at our final proof. The derivative of cosecant of x is negative cosecant of x times cotangent of x. That concludes our derivation from first principles. If you found this step-by-step breakdown clear and helpful, please make sure to give this video a thumbs up, subscribe to the channel, and turn on notifications. See you in our next study session.